Okay guys, so here's the next video for P.5 notes. Starting where we left off on example 6, subtracting rational expressions. I think they skipped adding because adding is the same process as subtracting, but subtracting is just a little bit harder. So remember, first we need to get a common denominator. And a common denominator is all the factors. Once we factor the denominators, it's all the factors multiplied together. So in this case, we don't need to factor the denominators. So our common denominator would just be x minus 3 times 3x plus 4. So we just need to multiply the first one by 3x plus 4. And what we do to the bottom, we have to do to the top. And we need to multiply the second one by x minus 3. And what we do to the bottom, we have to do to the top. So remember, we're going to distribute the numerators, but we're going to leave the denominators factored. So the denominator can stay x minus 3 times 3x plus 4. So we get 3x squared plus 4x minus 2x plus 6, because we're going to run this negative through this whole thing. So now once we combine like terms on the top here, we get 3x squared plus 2x plus 6 over x minus 3 times 3x plus 4. Remember, x cannot be 3, x cannot be negative 4/3. I did check to see if the top would factor. There are no two factors of 18 that add to 2. So there's nothing more we can do there. So you guys go ahead and try B. The answer to B is x squared minus 2x plus 3 over x plus 2 times 2x minus 1. X cannot be negative 2, and x cannot be 1/2. Okay, so in example 7, we have 3 fractions. So once we factor this, it becomes 3 over x minus 1 minus 2 over x plus x plus 3 over x plus 1 times x minus 1. So I have 3 pieces here, and my common denominator is x times x minus 1 times x plus 1. So what I need to do is multiply each fraction by the pieces I'm missing. So on this first one, I need to multiply by x times x plus 1, top and bottom. On this one, I need to multiply by x plus 1 times x minus 1. And on this one, I just need to multiply by x. So once I distribute, I end up getting 3x squared plus 3x minus, and I have to subtract this. So minus 2x squared minus 2, and then plus x squared plus 3x, and that's all over x times x minus 1 times x plus 1. Now I just need to run that negative through and combine like terms. So when I run it through, I get minus 2x squared plus 2. So I end up getting 2x squared plus 6x over x times x plus 1 times x minus 1. Now we have to say that x cannot be 0, x cannot be negative 1, and x cannot be 1. Now I can factor the top. I can factor out a 2x, and I'm left with x plus 3. And that is beneficial for me because I can reduce by an x at the end, and I'm left with 2 times x plus 3 over x plus 1 times x minus 1. So go ahead and pause me and try part B. But your answer should be 7x squared minus 13x minus 16 over x times x plus 2 times x minus 2. X cannot be 0. X cannot be plus or minus 2. So that's what you should have gotten for part B. Okay, example 8 is talking about complex fractions. So complex fractions are fractions that look like this, with separate fractions in the numerator, denominator, or both. So we're just going to break it down into, we're going to use the division bar instead of the fraction bar. So this is like 2 over x minus 3 divided by 1 minus 1 over x minus 1. So now we're going to treat this as a subtraction problem and this as a subtraction problem and get common denominators and then multiply by the reciprocal after we get one fraction divided by another fraction. So since 3 is like 3 over 1 and 1 is like 1 over 1, I'm just going to write it like that. So if I were writing this and getting common denominators, I would multiply this top and bottom by x and this top and bottom by x minus 1. So on the first fraction, I would get 2 minus 3x over x divided by 1, x minus 1 minus 1 over x minus 1. So now we're going to multiply by the reciprocal. So I've got 2 minus 3x over x times x minus 1 over x minus 1 minus 1 is x minus 2. So I've got 2 minus 3x times x minus 1 over x times x minus 2. And remember, x cannot be 0, x cannot be 1, and now x cannot be 2. So make sure you take care of all the denominators in all of the fractions. So B works the exact same, so pause me and try it. But your answer should be 3 times x plus 3 over x plus 2 times x minus 3. And x cannot be negative 2, and x cannot be positive 3. Okay, so simplifying an expression with negative exponents. So recall, when factoring a GCF, we factor out the smallest exponent of the specific variable. So if I have 5x cubed minus 17x to the 7th, I factor out the x cubed because it's the smallest variable. So I'm left with 5 minus 17x squared and I get that x squared by taking the 7 minus, not x squared, x to the 4th. What am I doing? I'm sorry. X to the 4th. And I get that x to the 4th by taking my 7 exponent minus my 3 exponent. So it's going to work the same with a negative exponent. So first I wanted to show you also it could work the same way if I gave you an example like 4 times x plus 2 to the 10th plus 7x times x plus 2 to the 3rd. We can still factor out that x plus 2 even though it's a binomial we're factoring out. So an x plus 2 to the 3rd power, and we're left with a 4 times x plus 2 to the 7th power, and then plus 7x. So the same goes for a negative exponent. If I have x to the 4th plus x to the negative 6th, and I want to factor out a greatest common factor, up here we factored out the smaller exponent. And the smaller exponent in this case is definitely negative 6. So we're going to factor out a negative 6. And then when we were figuring out how to get the remaining exponent from x to the 7th, we subtracted. So we're going to do that again. 4 minus negative 6 gives us 10. And that's how I figure out that I get x to the 10th power and then plus 1 because I factored out an x to the negative 6 out of x to the negative 6 to get 1 in this place. But when I factor out an x to the negative 6 out of x to the 4th, I'm left with x to the 10th. And then if you want to rewrite this with positive exponents, you would say x to the 10th plus 1 over x to the 6th. This also works the same with rational exponents. So let's say I have x to the negative 5 halves minus x to the negative 1 half. Negative 5 halves is definitely my smaller exponent. So I'm going to factor out x to the negative 5 halves. And I'm left with 1 when I factor out x to the negative 5 halves out of x to the negative 5 halves. I'm left with 1. But when I factor out an x to the negative 5 halves out of negative 1 half, I take -1/2 minus -5/2, which is 4/2, which is x squared. So I have 1 minus x squared. So I can write this as 1 minus x squared over x to the positive 5/2. So when factoring out a negative exponent, we're just going to subtract exponents to see what we have left from the other exponent. So let's try a couple. Here, -3/2 is definitely my smaller exponent. So I'm going to factor out 1 minus 2x to the -3/2. And I'm left with x plus 1 minus 2x to the, so if I have -1/2 minus -3/2, that gives me 2/2, which is 1. So now I have x plus 1 minus 2x over 1 minus 2x to the 3/2 because I want to change that to a positive exponent. So I have 1 minus x over 1 minus 2x to the 3/2. X cannot be 1/2. This is really similar. I'm going to factor out x minus 1 to the -4/3. And when I factor out to the -4/3, I get x minus 1 to the first power. So it's just x minus 1 minus x. So that causes me to get -1 over x minus 1 to the 4/3 because I always want to have positive exponents. And remember, x cannot equal 1. So once you kind of get the concept down, it's not that hard of steps to follow. So now we can use it to simplify, and we do this in calculus a lot. You're going to factor out on the top first. So we have 4 minus x squared to the -1/2. When I factor out to the -1/2, so 1/2 minus -1/2, I'm left with 2/2, which is 1. So I'm left with 4 minus x squared to the first power right here, plus x squared over 4 minus x squared. So this works out well because these two terms cancel, and then I'm going to send this term to the bottom so it becomes a positive exponent. So I have 4 over 4 minus x squared to the 1/2 times 4 minus x squared to the first power. Now when I'm multiplying something with the same base, I add the exponents. So I have 4 over 4 minus x squared to the 3/2. X cannot be plus or minus 2. So go ahead and try B. It works really almost the same. You end up getting 2x squared minus 2 over x squared minus 2 to the 3/2. And x cannot be plus or minus the square root of 2. And we're almost done. So finally, we're gonna be rewriting difference quotients. So we're gonna want to rationalize the numerator. So remember, to rationalize the numerator, we multiply by the conjugate. And that is when we change the middle sign. So when I multiply by the conjugate, I get the square of the first thing minus the square of the last thing. What we're going to do is leave the bottom factored. So what happens is your x's on top cancel, and then you have h over h times the square root of x plus h plus root x. Then your h's cancel. So you've got 1 over the square root of x plus h plus the square root of x. So something similar happens when we do this conjugate. We do the square root of 9 plus h plus 3, top and bottom. So we get 9 plus h minus 9, because when we square 3, it's 9. Then on the bottom, we get h times the square root of 9 plus h plus 3. So we get 1 over the square root of 9 plus h plus 3. And this is helpful because it'll say something like plug in h equals 0. And if we look at our original, we cannot plug in h equals 0 at first because that would give us a 0 on the bottom. But once we rationalize, now we would be fine to plug in h equals 0. So it's just manipulating the expression so that we can plug in certain values. So now you should be fine to complete the P.5 homework. Let me know if you have any questions.